Hey guys, so quick update on my project. All of my capacitors came in from Great Plains Electronics. I pulled the power supply boards off and I brought them home with me and I am going to solder them. So I just want to show you what my setup is like here. So got my computer, usually throw on some movie or YouTube videos or music, something to keep me occupied while I'm soldering here. So I have my boards. I have it down on an anti-static bag just in case. There are some IC chips here which are static sensitive. So I just want to make sure that none of these things get messed up. For my tools, I have a Weller soldering station. This is like, I think, 90 bucks on Amazon. I've fucked around with some cheaper soldering irons before, and spending the money on this was definitely the way to go. It heats up super quick. It's super controlled temperature. The tips are relatively cheap. They last a good time if you take care of them. It's a really nice soldering station. Next to that, I have the Hako 470, which is my desoldering station. So the key thing here is you'll note that there's two wires coming out. One for power to the soldering station and one for vacuum because it is a desoldering station. So at the tip here you can see that it's kind of hollow. And that's where you suck the solder through, and I got this little trigger here. So it heats up like a normal soldering iron, the tip gets hot, and then when you're desoldering components, it's super easy. You just stick this thing on there and it sucks all the solder out, and it's really easy to rip them out. Before that, I used to use the classic solder pump, and these things certainly work. They're definitely worth the money. I mean, this is like $9-10 bucks. Versus that, I think the cheapest new one on Amazon is like 300 bucks. I got this one used on eBay. I think it was like 150 bucks. But it is certainly worth every penny. This is certainly my most prized tool. So, taking a look at our boards here, I noticed there's a little bit more missing than I originally anticipated. So obviously there's a cap missing here. The legs were just ripped right off of it. I'll be replacing all these electrolytic capacitors like I mentioned before. What was the other thing? Well, I noticed here, so these are different capacitors. These are capacitors, but they are Mylar capacitors. Tantalum is another type of capacitor, and they kind of work the same way, but they're very different than electrolytic capacitors, which are these other ones. The big difference being that they don't have polarity, you know. These big electrolytics have polarity. They need to be put in a certain way or they won't work the way that they're intended to. So I noticed here that there is one that just got straight up ripped out. You can see that there's little remnants of the legs there. So I'm going to need to find out what part that is, and hopefully I have an extra one or I can find another. But I was also just kind of taking a little closer look at the board here. We can see that this transistor here is a little messed up. It got a little turned around. So I just want to make sure that these legs aren't touching. The transistor itself is probably good, but I just want to make sure it's not shorting itself out. It's getting kind of close there. Taking a look here, old capacitors. Like I mentioned in the previous video, I'm going to be replacing this bridge rectifier. The key thing here, I got the replacement right here actually. So it's 400 volts, 35 amps, and those are maximum ratings. I forget what this one was spec'd out at in the schematics, but as long as the part that you're replacing with exceeds what was listed in the schematics, you're going to be more than okay. It's just kind of like overshooting it and having more functionality than you really need. You know, it's over-speccing it. Looking again here, we see some leads from the capacitors that were ripped out. I don't know what the fuck this was. We see another lead here that was ripped out. This is also another little bridge rectifier. It's a little bit smaller. It won't get as hot. It's for lower voltages and lower current, assumably. So I'll replace that too, just because the part was cheap. And this is an even smaller bridge rectifier. That's a common symbol on there. You can see you got a plus and a minus on the bottom left and top right, and then those waves. The waves symbolize that it's AC coming in on those, and then the plus and minus are DC coming out in there. Another important thing to note here is it looks like there's this R27 missing. However, you'll note that the solder pads there are kind of filled in, you know, versus like this one where you can see that there was a hole there, there was a lead there at one time. These were not. So the way that they did it is maybe that was on the original design, and they decided to go against it. Maybe there was a last-minute change, and they decided not to use that part. You see it on monitors pretty commonly, on boards. This is the first time I've seen it on an arcade board. But regardless, you don't have to worry about it because those solder pads are filled in. So when they were making this board, they intentionally did that, and there's just no part there. Other than that, you kind of want to just take a look at the board and make sure that there's nothing too funny going on here. I noticed that this connection here and these diodes were a little funny, so I'll verify them with my multimeter. Again, I'm going to verify all these fuses are the correct values. Here's some other resistors here that weren't populated. It's another idea what they look like. So I spoke about last time about these connectors, and I said that they get hot over time because they're making an ideal connection. And that's okay if they get a little bit warm. So, you know, taking a closer look at these all look good. They're all clean. Nothing got super hot. However, because they're constantly getting hot and getting cold, you can get cold solder joints. I'm not going to go into detail on soldering and hot and cold solder points, etc. in this video, because there's plenty of other videos like that on YouTube. But you can kind of take a look here. So here's a really good example. This bottom pin here, you can't see it too well because I'm on my phone. That's actually pretty decent. You can see how there's kind of like a little cup. You can see where the pin is, and you can see where the solder is. And that's exactly what you do not want. That can cause a really shitty connection. I'd be surprised if that even works, frankly. Outside of that, you can see that all this solder is just kind of like a matte, flat metal color. So what the procedure is just to kind of heat it up and put some new solder on there, or quote-unquote flow new solder. And that'll make all the connections nice and shiny, and it'll make sure that they're making an ideal connection. Like I started saying, because the game gets hot and cold from running and being stored, these solder connections get cold over time. And even though all these kind of don't look perfect, the connectors are the big thing that you want to do. It's relatively easy and quick to do. You just got to kind of tap it with the soldering iron and touch it up with some solder. But another thing you want to look for here is any cuts in the circuit board. So you'll notice it kind of looks like it's wrinkling here. And this is actually a separate layer of masking that gets put on top. So each one of these like lighter green lines here is the circuit board trace. And you know, if this board got scraped against something, it's possible that like one of these traces got severed, and the circuit could be disrupted, and something could not work, or likely the whole thing wouldn't work. So even though it looks kind of wrinkly here, that's okay. This is just like the protective masking, just oxidizing and kind of lifting up over time, which doesn't really matter because this board isn't going to be pulled out. The idea is we're going to get it working once, we're going to put all new caps in, and it's going to work forever for the rest of its life. But you know, you want to check out the board and make sure that there's no scrapes, that there's none of these traces that are cut. On this board, the traces are pretty big because this is all high voltage stuff. But when you're getting down to logic boards, it can get kind of hairy. I've seen some really, really small traces that have been cut, and it's maybe under a chip and you can't even tell until you take it off, you know. So it can make troubleshooting a pain. So looking at this other board here, this is the one with the more ICs. You can see that the traces are a little bit smaller because it's smaller voltage that's being distributed throughout here. And also, these solder connections look a lot better. They're not nearly as many cold ones. And yeah, this guy, that's really what you want to look out for. I've seen some good pictures online of people showing how bad that is, but I mean, that's pretty obvious, you know. There's this whole like ring of solder around it that's all fucked up. So what I'm going to do is pull up the schematic and replace all these capacitors. So I was saying that the electrolytic capacitors, you can tell that because they're usually bigger, and they'll have a line here. So this is saying that the negative side is this side. These are passive devices, so they're just in plain packaging, versus the rectifier, which is a silicon-based device. It's technically sag sensitive. It'll probably be okay, just because it's not like an IC chip where there's a million different transistors in there. It's just a few chunks of silicon. But it does a good job either way with this packaging. That's how it should be packaged. The big thing you'll notice too is that these capacitors get a lot smaller over time. You know, this is a 15,000 microfarad capacitor. The one that's supposed to be in here is an 18,000, but this is more than enough. And I mean, the one that I found in the bottom of that Robotron cabinet was easily 4 times the size of this, the volume of it. So it's kind of nice you get kind of smaller parts. You'll notice that. Another thing to look out for, I've seen this on arcade monitors. This is the first like real kind of separate power supply board I've done for an arcade game. But sometimes when you're doing a cap kit for a monitor where you're replacing all these caps, they'll have different schematics. Or the schematic rather will call for a different value of capacitor, or will say that the polarity is different. Like I was saying how capacitors have polarity. So you can see here on this capacitor, there's a plus sign right there, and that's telling you where the positive is, and this is where the negative is. On the contrary here, you can see that this capacitor is this is the positive lead and negative. And so this like white ink on top of here that tells you that that's a silk screen that they etch on top of it. And when I'm doing an arcade monitor, I got a kit from Bob Roberts, a cap kit, and it said specifically like this one is mislabeled, so watch out for it. So it'd be ideal if these capacitors were still in here. You take note of the polarity that they're currently in, and just make sure that that matches up with the silk screen, just to make sure. And just also to be sure, I also pull up the schematic at the same time and make sure that the value of the capacitor that I'm replacing matches what's in there now and matches what's being put in. So outside of that, it's just labor now. Pull out these capacitors. I do them one at a time. Very important. Do them one at a time, because you will forget what goes where and things are going to get all jumbled around. Taking a look here, this transistor kind of got messed up. It looks like it got banged around and it's kind of laying down. So I'm going to straighten that guy out and make sure it's not shorting out. It may have, yeah, it already looks like it already was shorting out, so it may have gone bad. Hopefully I have a replacement. I don't know if I pointed this out before, but this was another Mylar capacitor that just got fucked up. You can see it's half of it's still here, and it's just flush against the board. So, you know, you also have to take this into consideration, like something smashed that into it, you know. So here's another example. This capacitor is leaning over. You know, it should be straight vertical, and it's at a 45-degree angle, you know. So what caused that, and what else, when that damage was inflicted, what else did it hit, you know? So it's just kind of taking a look at the evidence here and seeing what's at hand, and making good judgments off of that. This board on the left here actually looks like it's in really good shape, except for this guy. Obviously it's okay. But either way, replace all the capacitors, do them one at a time, take your time, use the desoldering iron, buy a desoldering gun. It is the best soldering purchase you will make. Cool, so I'll do this. I'll bring it back to my brother's house, and we'll try it from there.